Hello boys, welcome to another video. Please subscribe if you haven't subscribed. Hit the like button, share my videos with your colleague, your friends or someone in need. Support us on Patreon and do watch this video till the end because it's gonna be exciting. In this video we are going to share with you a project. It was for a client and it was a kind of an urgent project which we got signed and delivered in 3 days. The aim of this project is to design, develop and deploy a high-speed internet access system for about 3,000 to 4,000 people staying in that labor camp, which we did successfully, alhamdulillah. I'm not going to get into the detail of how it was done and what are the technologies we used, but some of the technologies which we will be using will be shared with you guys in the video. So in this video we will be getting the hardware, testing the hardware, configuring the hardware, deploying the hardware. The testing will be done on the client side, so we will not be including the testing phase. The system we are going to deploy will be captive portal system, means it will be an hotspot network where you will have to enter the credentials, either vouchers or username, password or PIN numbers, whatever you have, and then it will allow you to access the internet or the network. So in order to accomplish this, we will be using, of course, physical hardware, physical server and an hypervisor on it, which will be Proxmox, our favorite. We will be using our own product, which we have named CHIS, spelled as CHIS. It is specially built for labor camps, labor accommodation. It has all sort of fancy stuff, receipt printing, vouchers printing and vouchers access control and whatnot. Everything you need to run a labor camp internet access system is built right into it. So we will be installing that. We will be attaching a point of sale in the remote side. Of course, the point of sale is from the client side. We will be attaching a printer, a receipt printer, 80 thermal printer to print receipts or vouchers from. And then we will be connecting our code switch with our server with a 10 gig network connection. We will be using MIKROTIC CHR to handle all the authentication, to handle all the routing, to handle all the firewall, load balancing and hotspot and whatnot. Everything will be done by the CHR. And we will be using 4 to 7 internet lines, 600 MBs each. Of course, load balanced, failovered and tuned for high speed internet access. So I think we should get right into it. Please don't forget to subscribe. Please don't forget to watch the video till the end. So let's begin. Okay guys, this is the server laid upside down. This is the core switch, which we have a problem loading. Excuse my McDonald's and my trash. Huh?
Don't show them the trash.
But they will ultimately notice it, right? We have the 10 gig module installed. Okay boys, we've got the server, we've got the code switch. Can you show them? We managed to load it successfully without tearing up our seats. And now we are headed to another warehouse where we will get the remaining of the parts we need for this project to work. So see you in a minute. Bye bye. What a sunny day it was. Whoa, whoa, whoa. Corvette. It somehow managed. So going from one point to another. It was a sunny day, a real sunny day. First day of Ramadan,
fasting, no AC in the car. It was a hard day. And it was very hot. 42 point something degrees to be exact.
Alright boys, we've secured the hardware. We've got what we needed. Cisco core switch. This will be Cisco 4500 series core switch. If you can see, it's still wrapped. I'm just going to unwrap it. We've got some SFPs, multi-mode. We've got a cable. I know it's not recommended to fold a optical cable like that, but power cables. We've got a MIKROTIC CR 1009. It also supports 10G. SFP plus, SFP, and around 12 or 7 Ethernet ports. Right, with 2 power source, 2 fans. Okay, and we also got Dell PowerEdge R720 with the 3500 GB SATA hard drives and 2 6-core XEON processors, 64 gigs of RAM. So let's get this thing unpacked and hook everything else together.
You will find all of my fast forwards on Patreons with audio on normal speed without any editing. It will be uncut videos.
Okay, here it is. I think I'll show you the insides. We have 6 fans, two CPUs, and not more, not much, but 64 gigs of RAM, 2 power supplies, 1100 watts each, 4-port Ethernet module with the okay, it's a dual port 10 gig SFP plus NIC from Intel, and this is pretty much it for the server. It also has a DVD. All right, the server is okay. Let's close this thing up. It's closed. All right, let's move the server away and unbox the core switch. Unwrap the core switch, and let's continue.
The server was not heavy. Oh my god, it was a treat unwrapping the beast.
All right, some fillers and spacers are missing. Otherwise, I'll show you. What do we have here? We have a 4506E core switch. It's a switch. We call it core switch because it sits in the core side of the network, core switching side. It has a WS-X54 Super LE supervisor card, which has an uplink of 10 Gbps, 2 uplinks, and it has a console management interface. It comes with 48 port PoE module itself, blade or whatever you call it. The other one is 24 port SFP blade or module or whatever you call it. Okay, we have 3 spare. We have 1 filler, 2 we'll be getting tomorrow. We have 1-sided rack mount ear, 1 missing, we'll get this tomorrow. We have hot swappable 1100 watts, I guess, or 2800 watts power supply. I'm not sure, but it gives us 2800 AC voltage. Alright, so let's turn this thing on.
Now while I turn this thing on, you might want to lower your volume, and if you're using headphones, then be careful because this is going to be loud, very loud, because the server itself was having 6 fans, 4 fans for the exhaust on the core switch, and 2 big fans on the power supply intake, so it was loud.
Alright, one thing powered on, the other thing is powered on. We have power to the core switch. You should have power to the server as well. Okay, we have power to the server. We'll turn on the server first. Okay, that is some powerful fans right here. I'll show you. So I will quickly connect my display with the server. I'll bring up my laptop, connect the core switch management or console interface with my laptop and see the output. Alright, the server and the core switch are up. I think they've done booting up. The noise of both of the equipment is too much. It is alrighty, right. We have a display and we are going to install hypervisor on it. It's called Proxmox. I will make sure that I have the latest one. I will be installing Proxmox hypervisor, bare metal hypervisor, configuring the core switch for basic connectivity. And for the testing purposes, I use my MIKROTIC Cloud Core router CCI1009 to check 10 gig connectivity, because I wasn't so sure about the NIC which came with the server to support 10 gig, because on the datasheet it said it was in hybrid NIC. It supports fiber channel plus Ethernet protocol, so I wasn't sure. I thought there was some kind of a settings you have to do on the BIOS or somewhere in the utility to enable the Ethernet to work on the fiber channel NIC, but I was wrong. It was all plug and play and the performance was quite good. So here we go. Enjoy the show. And for some reason
my console cable didn't work. For that same reason, I have about 5 to 6 different console cables, about 2 different USB to serial adapters, converters, so that if one doesn't work, I'll have another one. And if it doesn't work, then I have another. Sometimes I use the built-in serial interface and the servers to connect to the switches, to the code switch, or to the hardware I'm configuring. And after the configuration, basic configuration, I enable I enable SSH or Telnet, and then I directly connect the equipment with Telnet or SSH. Too much noisy, right? So what we are doing now is we are installing an OS on our servers. We are booting up the core switch. Initially it went on to the ROM on mode, which is like a recovery procedure. Look at that. Look at the speed. Look at the speed, 6 core. Look at the hard drive spin. These fans are noisy and super fast. Is it? Okay, it's up. It is up. The switch is up and running. We'll have to check the connectivity. For that, we can turn on our MIKROTIC. Alright, time to test the 10 gig connectivity. This was not the part of the deployment or the project. I just did this only to test the 10 gig before the Proxmox even installed and boot up. It was just out of curiosity. And remember guys, you can find all of my slow motion videos on Patreon. If you support me on Patreon, there I will give you the link of all the fast motion video clips which I included in this project. I will include the diagram, how I configured, what tools did I use, and how everything is connected, all on Patreon for my Patreon supporters. Alright, it says 10 gigabit is up and running. Alright, installation successful. We have a successful install on the Proxmox. You can remove this one. Transceiver has been inserted. Alright, so let me connect my Ethernet from my router to the laptop. Okay. 10 gig is showing on the interface on MIKROTIC as well. So my cable is okay. My X2 interface is okay. My SFP Plus interface in my MIKROTIC router is okay. And I have a link. Alright, so what we've accomplished so far, we installed an operating system on our servers. We've checked the connectivity between the core switch to our router. It's connected at a link speed of 10 Gbps.
So the modules are working, the core switch is working, the fiber optic cable is working. Now we need to make sure that the 10 Gbps link has appeared in our Proxmox. So the purpose or the mission of this deployment installation is to provide internet access to around 3,500 users in a labor camp, and that requires about 6 to 8 internet connections, so of 600 MBs per second. So the aim here is to use the Intel Xeon processor performance leverage and to provide internet access to those concurrent users. That is my youngest brother. Never seen a core switch before with this many fans, this powerful airflow, this many SFP interface. He was amazed. So he was just taking pictures, and it's too much time spending on video. Just waiting for the installation process to finish. So I'll finish the installation process and I'll continue from there. Alright everyone, we have finished the configuration. We have configured everything what we needed, and we are off to the deployment site. The server and the core switch are loaded in my car, and we are just heading to the site. It'll be a long journey, about 400 kilometers from where we are now, and we'll show you around. We'll show you when we get there. Switch and the server both loaded. Not the most practical car for this purpose, but it serves well, and I just love my E46. I hope you guys do. All right, let's go. Let's begin the journey. See you when we get there. Now, because we were getting late, we rushed at a speed of 160 kilometers an hour, and we forgot to shoot our B-rolls. So let's get direct to it. And this was their existing setup. They were using IPCOM switches to connect all their IDFs and access points and other intermediary equipment. And because we couldn't find the rail mount for the server, we had to just slide the server on top of an existing shelf. And because of the cabinet was not a server cabinet, it was a network cabinet, which is not enough for a server. The length is not enough, and we just improvised and used the shelf to keep the server on top. And because we need to free about 9 U's of rack space for the core switch, we had to remove the existing Cat6 or Ethernet switches used to connect God knows what, and replace the switches with the core switch. We had to relocate everything on the cabinet to accommodate the new hardware. We also didn't have enough rack mount cage nuts, because these are the things which customer has to provide. Otherwise they have to notify us beforehand so we can get everything what we need to do the installation. And because it had about 8 holes or 8 points to mount the core switch to the cabinet, we used only, I think, 4 of these. And because the core switch was placed in the bottom of the cabinet, we didn't have to use all 8 or 6 screws to secure the core switch to the rack. And it was very heavy also, weighing about 45 to 50 kilos. And that's me improvising with the exact placement of the cage nut.
And because this was a remote site, very far away from a city or from a hardware store, we had to improvise and overcome and use whatever that was available. And it was a very critical deployment. We have to finish on the same day because 80% of the labor was standing outside the data center, just waiting for the network to be up so they can use Wi-Fi and the network to call their loved ones, to use the internet, and to get online. Now, because of the corona situation, most of the labor camps, they are like in a type of quarantine. They are not allowed to go out for work. Nobody's allowed to come in. Nobody's allowed to go out, except if it is for a very critical purpose or very important purpose. And because of that, most of the labor standing outside were shouting and they were eager to get online and to connect with their loved ones. Total of 4 guys installing a core switch, 9U core switch to the rack. That's me fastening the core switch to the cabinet. I know I talk very slow, right? Okay, time to connect the power and time to connect the cables and the SFPs and connect the core switch with the server and see if everything boots up. Now, because of the installation was pre-set up in my home, I almost set up 98% of the server and the core switch. All we have to do was to enable WAN interfaces, configure load balancing, and that's it. Right, so connecting the core switch, connecting the power for the server. Okay, should be alright. I just wanted to connect the 10 gig link to the server before we turn on anything. Right, the server is turned on. The core switch is turned on as well. It turned out that one of the cables, power cables, were not okay. I think fused maybe, or damaged cable. I happened to check only one cable, so I switched, and yes, the cable is damaged. So we'll remove the cable, and just one is enough. Because of the power supply is 2800 watts and our consumption is not that much, because we will not be using too much of PoE power. I think only one access point will be powered from this module, CHISOP, powered by VNS Group LLC. CHIS is our product. Here is the finished product. This was the finished setup after we configured all the IDFs and everything was turned on, all the VLANs, all the Ethernet, all the WANs, everything was set up. Now this is bulk printing of our internet access vouchers. I removed the audio because it was too loud. There were about more than 300 guys outside the data center they wanted to get online. We are just printing about 1200 vouchers to just mass distribute. These were just trial 24-hour access, or I think 1 week access vouchers. This is our control front panel. This is the network running. Slow-mo shot. And one thing you might notice is the Huawei SFP switch, which we had to turn on because the client ordered multi-mode SFP module, but all the cables and IDF were connected to via single mode fiber. So we for a minute thought connecting everything to the Huawei switch and then connecting the Huawei switch to the core switch. But initially we managed to enable third-party SFP support on the core switch. While moving out, these were the guys waiting for the internet access.
Alright boys, we finished the installation yesterday and everything is working smooth as intended as well. Now we are at my dad's workshop. It's a carpentry workshop and we are heading home, so see you there.
It was a very hot day, especially when you are fasting, no AC in the car. It is a very hard day. The Dubai frame. Alright boys, thank you for watching the video. Please subscribe, support us on Patreon, and do share the video, comment, like the video. Stay safe, stay home. Assalamu alaikum.